Defining cloud computing. Cloud computing represents a paradigm shift in how computing resources are created, managed, and utilized. It allows users to access vast computational capacities and data storage over the Internet, eliminating the need for physical hardware on a local level. This model provides scalability, flexibility, and economic efficiencies that traditional computing cannot offer. By utilizing shared resources, cloud computing enables on-demand availability that can be adjusted quickly to meet variable needs, thus supporting innovation and agility in business processes. Historical background and evolution. The concept of cloud computing dates back several decades but gained significant traction in the early 21st century. Its roots can be traced to the 1960s with the notion of time sharing in mainframe computing. The term, cloud computing, began to emerge in the late 1990s when telecommunications companies started offering virtual private network (VPN) services. An essential milestone was the launch of Amazon Web Services (AWS) in 2006, which democratized access to cloud infrastructures. This development sparked a global shift as organizations recognized the value of migrating their services to the cloud. Over the years, cloud computing has evolved with advancements in virtualization, distributed computing, and network bandwidth, among other technologies, driving widespread adoption across industries. The core components of cloud infrastructure. The infrastructure of cloud computing is fundamentally composed of three main components: compute, storage, and networking. These elements work in tandem to deliver cohesive and efficient cloud services. Compute. This involves the processing power required to run applications and manage workloads. Cloud computing offers virtual machines and containerization technologies to handle these processes seamlessly. Storage. Storage solutions in cloud computing provide scalable and durable options for data retention. Object storage, block storage, and file storage are prevalent forms that cater to diverse data storage needs. Networking. Networking in the cloud facilitates the connection of resources and transmission of data. It employs virtual network interfaces and advanced load balancing to ensure optimal performance and availability. These components collectively form a robust architecture, supporting applications and services hosted in the cloud, thereby empowering businesses with enhanced computing capabilities. Cloud service models explored infrastructure as a service, IaaS. Infrastructure as a service, IaaS, offers basic computing resources like virtual machines, storage, and networking. This model grants users control over operating systems and applications while the provider manages the underlying infrastructure. IaaS is advantageous for businesses seeking elasticity and scalability, enabling quick response to changing demands without the need for significant upfront investments in physical hardware. Platform as a Service, PaaS, details. Platform as a Service, PaaS, provides a robust framework for developers to build, deploy, and manage applications without the complexities of underlying infrastructure management. This model abstracts elements like operating system internals, databases, and storage layers, allowing developers to focus on coding and application enhancement. PaaS accelerates development cycles by offering integrated development environments, middleware, and business analytics. Critical features include automated scaling, security, and backup services, ensuring applications remain agile and protected. Software as a Service, SaaS, advantages. Software as a Service, SaaS, delivers software applications over the Internet, enabling users to access them via a web browser rather than installing on local machines. The SaaS model benefits organizations by reducing software management complexity, facilitating updates, and lowering costs associated with maintenance. This service model caters to high user accessibility and collaboration, promoting real-time data sharing across locations. Furthermore, SaaS solutions are typically subscription-based, offering financial predictability and scalability. Comparing public, private, and hybrid clouds. Public, private, and hybrid clouds provide varying deployment methods to align with organizational needs. Public clouds operate on shared infrastructure managed by providers, offering cost efficiency and flexibility for less sensitive data processes. Private clouds, in contrast, are dedicated environments ensuring greater control and security, ideal for businesses with stringent compliance requirements. Hybrid clouds combine public and private elements, balancing flexibility and security. This model allows data and applications to move seamlessly between environments, optimizing performance and resource utilization. Organizations must assess priorities such as scalability, control, and data sensitivity to select the most appropriate cloud deployment approach. Security implications in cloud computing. Identifying key security concerns. Cloud computing offers numerous advantages, yet it brings specific security concerns that demand close attention. Central to these concerns is data breaches, where unauthorized access to sensitive information can occur. Additionally, insider threats, where employees misuse access permissions, pose significant risks. Another critical issue is data loss due to accidental deletions, malicious attacks, or outages. Moreover, inadequate identity management can lead to unauthorized access, complicating the maintenance of secure environments. Finally, security misconfigurations in cloud settings often result in vulnerabilities, exposing systems to potential exploits. Compliance and regulatory requirements for organizations utilizing cloud services. Compliance with industry regulations and standards is pivotal. Cloud providers and users must understand various regulatory frameworks, such as the General Data Protection Regulation, GDPR, or the Health Insurance Portability and Accountability Act, HIPAA. These frameworks mandate stringent data handling protocols to protect user information. Moreover, adherence to these standards not only ensures legal compliance but also enhances trust with clients and stakeholders. Failing to comply can result in hefty fines, legal ramifications, and reputational damages. Therefore, organizations should meticulously evaluate their cloud providers' compliance certifications and understand the shared responsibility model in cloud security. Data privacy and protection mechanisms. Ensuring data privacy and implementing robust protection mechanisms are of paramount importance in cloud computing. Data encryption, both at rest and in transit, is a fundamental component that safeguards information from unauthorized access. Access controls and authentication processes, such as multi-factor authentication, MFA, further bolster security by verifying user identities before granting access. Additionally, organizations must employ data masking and anonymization techniques to protect sensitive information in non-production environments. Regular security audits and vulnerability assessments are crucial for identifying potential weaknesses and rectifying them promptly. Through these strategic measures, cloud users can significantly mitigate risks, ensuring that data privacy and protection remain intact. Maintaining vigilance in cloud computing security not only protects sensitive data but also builds resilience against emerging threats. By addressing key security concerns, adhering to compliance requirements, and fortifying data privacy measures, organizations can navigate the complexities of the cloud environment while safeguarding their assets effectively. Economic impact of cloud adoption. Cost-benefit analysis of cloud solutions. Cloud solutions present a significant shift in managing IT expenditures. The financial implications revolve around a detailed cost-benefit analysis. Initially, businesses experience reduced upfront capital expenses since cloud services eliminate the need for extensive hardware investments. Instead, operational expenses dominate, as businesses pay for services based on actual usage. This pay-as-you-go model can potentially lead to cost savings, particularly for small and medium-sized enterprises, SMEs, that may not need a full-scale infrastructure. However, organizations must consider potential risks, including security and downtime, as part of their cost-benefit evaluations. The balance of these elements defines the financial viability of cloud solutions within various sectors. Cloud technology and business scalability. Business scalability is another dimension of economic impact driven by cloud technology. Unlike traditional infrastructures that require significant investments and time to scale, cloud solutions offer immediate scalability. Enterprises can adjust their resources dynamically to meet demand fluctuations without incurring substantial time or financial costs. This flexibility supports rapid business growth and offers a competitive edge. The ability to scale operations quickly and efficiently aligns with the dynamic needs of evolving markets. Consequently, cloud technology becomes a strategic asset in business management, fostering innovation and responsive scalability that traditional models cannot match, enhancing both competitiveness and resilience. Effect on global IT spending trends. Cloud computing also critically influences global IT spending trends. The shift towards cloud adoption reshapes how organizations allocate their IT budgets. Traditional IT investments, characterized by heavy capital expenditures on physical infrastructure, see a decline as businesses embrace the cloud's utility-based model. Reports indicate a steady increase in investment towards cloud services, reflecting confidence in the cloud's reliability and performance. This trend suggests a paradigm shift where cloud computing not only optimizes cost structures but also fosters technological evolution and innovation. As cloud adoption widens, global IT landscapes transform, indicating a continuing trajectory towards enhanced efficiency and technological advancement, reflecting broader economic trends.